No, the science guy, Rick Crosslin, is here, and he's got a lot of experiments, so I want to get them all in. So start with number one.
Kitchen science, right?
Kitchen science. I was going to call it kitchen chemistry, but there might be some physics going on.
Yeah, I bet there is. Yeah.
So why do I do this? If you have children at home, or if you have just want to learn more about science, we can actually do some things right out of your kitchen. So you don't need a science lab. Your kitchen is a science lab. So the first thing I want to do is, like, this is, a lot of these you can see on the internet, but they all have science behind them. These are Skittles, and they have 5 different colors. But
you're not going to ruin them, are you? I love Skittles.
It depends on your definition of ruin. But I got some warm water in there, and I started that one because I want to see what's going to happen here in a few minutes. What's going to happen is each color is made of a different element, and we have what's called diffusion. Diffusion is a science thing where you go from something concentrated to something less concentrated. Yep. So right now, you see those colors? They're all moving away from a high concentration into the center. And
they're going to form a rainbow effect?
Yeah, and we'll let that'll keep going. I started that first of all. So we're really talking about mixtures and solutions. So,
quick question.
Yeah.
I'm asking for a friend. What's the difference between a mixture and a solution?
That's a good question. So it's a liquid. So this is a mixture, salad dressing, because it's a mixture where the things inside of it are not completely in the water. Now this is a solution of salt water. I've dissolved salt in here, and it's very difficult to remove that out of there. Air is a mixture of oxygen and nitrogen and argon. So mixtures and solutions are kind of cool, but there's a special type of solution. And this is one of my favorite books.
Before you go on, look at that plate there.
It's so gorgeous.
Now, these are concentration gradients, which means a fancy word for saying the red may be thicker than the green. And watch what happens when I swirl this. Let's see if I can turn it one time. And it goes, it's out, it's like out of focus, but I put it back. That's kind of fun to do. And that's because it'll hold up to those for a while. That's just a great thing to do. Skittles, easy to do. You know, solutions, mixtures. This, though, is a weird thing. There was a scientist, and his name, Randy, you want to take a guess what scientist studied this in the 1700s?
Mr. Newton?
Isaac Newton. Very good. And he
I was there for the pre-show meeting.
So Isaac Newton studied how liquids perform. But this is a non-Newtonian liquid or fluid. This is cornstarch, like half water, a cup of cornstarch. Now, it acts both like a solid and a liquid. So, Kayla, take your finger or your thumb and push it really hard. Bounce it off there really hard.
Oh, wow.
Take your fist and pop it one more time. Now, okay. Now do it real slow.
Weird.
So when you put a force on it, this cornstarch is made of both water and cornstarch, and then there's a shear force. When you push against it, the water moves out of the way, and then the solid powder comes together. So this is fun to do with your kids because as long as you keep pushing it, look, as long as you keep pushing it, it stays hard. Here, Randy, get ready.
You're going to hit me right here, I'm sure.
Go ahead. But as soon as you let go of it, keep it moving, keep putting a force on it, and then hold it over there and see what happens. So
that is so fun.
Hold it over. That
starts to break up.
Yeah, just hold it over and watch with 2 fingers and watch what happens. It turns back to a liquid.
Endless entertainment for the children. And all it takes is cornstarch?
Cornstarch and water. And there's a great book called Oblique about stuff like that falls down.
Cool.
So this one, here's another way to make solutions. You know, in your kitchen, you have all these different things. So I have water, which I colored. And you can make some different density layers. And this is just some oil, vegetable oil. And you know what? Water and oil, what? They don't mix. They don't mix because of their properties. And I probably do this a little bit slower, but there's a layer of oil and water, and this stuff is the old corn syrup, Karo syrup. And what do you think? It's very thick. Where's it going to go, do you think?
It should go to the bottom.
Should go to the bottom. And this stuff, is it going to the bottom? I think it is. And so you could have some fun with your kids learning about different properties, and I'll put a bunch of that in there out to make it too big of a mess. And then finally, some alcohol, isopropyl alcohol, and where do you think that might go? Well, the best way is to find out. And so with a little food coloring, you end up making some different layers. The kids like that.
Yeah.
One of my favorite, though, is
I think I know what you're going to do. This is a fun one. So.
This one, a weatherman knows this one.
Absolutely.
So I have an egg here. I'll let you hold that.
Okay.
And it's got some oil on it. That helps better. And I'm going to ignite and drop this in. And then, Kayla, you put the egg on top
Stand
of it.
back, Kayla. Stand back.
What you're
Just
gonna
put it
see-
on top.
Yeah. You want to practice? Yeah, boom. Okay. No, but after I light it.
after you light
Here we
it.
go. And my time is almost up. I hate that.
That's his timer.
All right. Kayla, quick.
gotta do
Now watch it. Bounce. We hope. Bounce. And
Wait, this is really fun.
then all that air is taken up in the atmosphere.
The pressure
is-
difference.
Pressure difference. Boom.
I like
And
it.
don't forget vinegar and baking soda. Put them together, a chemical reaction. Oh, stop my timer.
What about your new Facebook page, real quick?
Oh, yeah, thanks. So I do a lot of science shows across Indiana, across the country, and so I put up a Facebook page. If you're interested in a science party at your home, at your school, at your wherever your business, hey, science will travel because science is for everyone.
I love it. Thank you so
Nice.
much, Rick.
Kids love it.
What's happening? What's happening?
Well, chemical reaction.
All right, awesome.